So you're going to find the perimeter of the rectangle shown. Essentially, it's a triangle. It's two triangles, two right triangles within this rectangle. So we're going to use the Pythagorean theorem to find the missing side length, and then we can find the rest of the sides. So we have Pythagorean theorem that we're going to write over here. A squared plus b squared equals c squared. And just so you remember, a squared and b squared are the legs, and c squared is the hypotenuse. Great. So we have a squared and b squared. C squared is the hypotenuse. So we're going to plug these things in. Hopefully this is a review for you guys, and you've seen Pythagorean theorem before. It may be a little fuzzy because it's not like you did it last week. It's been a long time. So we're going to plug these numbers in. Just make sure you realize that we're only really looking at like this triangle, not the rectangle as a whole. Just looking at that triangle. I put my right angle here because it's a rectangle and it has 4 right angles. And then one way you can identify the hypotenuse, if you're confused, it's the longest side, but I don't know, some triangles are harder to see. It's harder to see than others. So this, you can always go from the right angle and point across to the hypotenuse. That arrow will always point to the hypotenuse. And then the legs will always touch the right angle. So just a little trick to help you figure that out. Then you have x squared plus 5 squared equals 13 squared. So you've got two options here. You're either going to like add the numbers or you're going to subtract the numbers, depending on what you're given. If you're given the hypotenuse, like in this case, the hypotenuse and one leg, you will be subtracting. If you are given both legs, you will add. So in this case, I mean, it's essentially you're just solving an equation now. So we're going to bring that x squared down. Whoa, I don't know why I put 11. So we're going to bring that x squared down. And then 13 squared minus 5 squared is 144. But I'll show you in the calculator. 13 squared minus 5 squared. And then your last step is always to take the square root, because we don't care about x squared. We want to know what x is. What is x? It's the square root of 144, which is 12, because 12 is a perfect square. So if x is 12, but it's asking for a perimeter of the shape, you have to realize this is a rectangle. The opposite sides are the same. So we have 5, 12, 5, and 12. We add them all up together and we get 34. That is the perimeter. So, I mean, hopefully a lot of that was review for you, but if it's kind of fuzzy, I mean, this isn't the only problem we're going to do. So, all right, we're going to move to a little bit more of a challenge problem down here, because it's still Pythagorean theorem, but you have to draw Nadia's path in order to figure out what's what. So, anybody remember never eat soggy waffles? Or, I don't know, there may be other ones, other like acronyms that you remember, the north, east, south, west. But we're going to use this because notice north and east, she's skipping. So we have Nadia, she's going to end up, you know, going this way based on the north and the east directions that I see. So because of that, I'm going to start her down here. So we're going to say start. That's where Nadia starts. And then I'm going to use my ID to be a straight edge. And I've got Nadia going 3 meters to the north. I don't know. That looks like 3 meters. How about it? And then now she goes 3 meters to the north and then directly 2 meters east. They kind of look the same, but 2 should be a little shorter. Or 2/3 the length, I guess. 4 meters north. It's probably not going to be drawn to scale, but that's okay. And then 13 meters east, so that's a lot. We're going to make a long line to the east. And then 1 meter north. So one more tiny little one north. And now we have our endpoint. So she starts here, she ends here after all this skipping. So we need to figure out, all right, what's the distance between the start and that endpoint? And in order to do that, we need a triangle, because we're going to use Pythagorean theorem to do this. So I'm going to make like a little dotted line to draw my right triangle. And you may look at this and just say, okay, this is like a hot mess of all sorts of squiggly lines here. But what's happening is she has moved a horizontal distance and she's moved a vertical distance. Okay? The horizontal distance would be like the east values. So to figure out that horizontal distance, you're simply adding 2 and 13. So that is that horizontal distance right there. And I'm going to circle 15 because I have these circled up here. So they kind of match. Maybe that's helpful for you guys to see. And then I'm going to underline the northern numbers because those are the vertical distance. That's the change vertically. And so we add those together, 3 plus 4 plus 1, and we get 8. So I'm going to underline that one because that matches the underline there. But yeah, now you have the two sides to this right triangle, the two legs. So we want to then plug them in as a squared and b squared. So 8 squared plus 15 squared. You add those together, you get 289. And if you know your perfect squares, you don't have to use a calculator to figure out that that's 17. Because the square root of 289 is 17. All right, we're going to go to the next page. So far, we have not had any simplifying square roots. We will on the next page. Just remember, there's no decimals today. So as we move into the next problem, well, I think it's 2 problems away. We will simplify radicals. Okay, so yeah, I wrote these parentheses on here for a reason. So we're just going to keep them on here so we don't forget to type them into the calculator. So that's going to cancel out. X squared is this, but in order to get this, we must subtract this. So let's do that in the calculator. So we're going to do parentheses, 6 square root 3. All right, and then this is the trick. So just pay attention to what I'm doing here. You want to click this arrow. And once you click that arrow, it closes the, you can then close the parentheses. And then you're going to square it. Why is this important? I'll show you. You get a different answer if you don't do that. All right, and then subtract parentheses 2 root 2 squared. 2 root 2, right? Yeah. Nope. And you get 100. So, I mean, it's not too crazy. You have to have those parentheses so you're squaring all the things. So if you don't put those parentheses there, then you're going to get 14 and it's going to be wrong. And you will be sad because you will get points off on the test even if you knew how to do the problem. You know, just use parentheses. This is my diatribe. I'm done now. Okay, let's go to this one. So we have a trapezoid, but we're going to turn it into a triangle and a rectangle. And we're going to use the things that hopefully we remember about rectangles in order to solve for one of these side lengths. 2 of them. Yeah, that's exactly right. So we have 4 here, and this opposite one is also 4. And then in order to figure out this length right here, some of you just can look at it and you're like, well, there's 13 over here and 7 over here. Let's subtract. But yeah, that's what we're going to do. This length is 7. The entire length is 13. So we have 6. So we can plug that into 4 squared plus 6 squared equals c squared. And if you're like, whoa, 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 we're going too fast, cover this up and look at it now. triangle. 4 and 6 are my legs. So that's where that's coming from. We have 16 plus 36, so we get 52 when we add those together. And then here we go. This one can be simplified. So let's simplify this radical. So we're going to do 52 here divided by x. If you weren't here yesterday, this is what we went over. So you will need to watch that video from yesterday. But you are looking for the largest perfect square that goes into 52. And 4 goes into 52. And if you're thinking to yourself, is that the largest perfect square? How do I know? It is the largest because 13 is a prime number. Nothing else can go into 13. So 4 has to be the biggest. So we split those apart. We simplify the 4 to a 2. And then our final answer is 2 root 13. This side length is the hypotenuse for this right triangle on the right. And it is the leg for the triangle on the left. So I'm going to write hypotenuse here and leg here. If that confuses you, you don't necessarily have to write that in. But it helps me, so I'm going to write it. So we have 4 and 6, and oh, we already did that over here, so I'm going to steal that work that we did. And it's square root of 52. And why don't I go ahead and simplify it, you ask? And I'll tell you, it's easier to plug it in just simply as the square root of 52. This is not your final answer. It doesn't need to be simplified. Your final answer will need to be simplified. This one does not. So we can then use it as a leg, because if it's square root of 52 for the hypotenuse here, like this is the same leg length. We can plug this in. And then x squared plus square root of 52 squared equals 8 squared. How did I know where to plug these things in? 8 is the hypotenuse. X and square root of 52 are the legs. All right. One little thing I want to show you. Make sure you guys realize this. Square root of 52 and when you square the square root of 52, it just becomes 52 because those are inverse operations. They're opposite of each other, just like adding and subtracting are inverse. So if you take the square root of a number squared, you will just end up with that number. Nothing happens. All right, so x squared plus 52 equals 64. We're going to subtract 52 on both sides. X squared equals 12. All right. And then you need to simplify this. You say you didn't know how to do this, so this will be a good time to listen. All right, we have 12. It's a small number to simplify. This is square root of 12. So hopefully you guys can see that 4 will multiply evenly into 12. 4 is a perfect square, one of those we talked about yesterday. So we split this into the square root of 4 and the square root of 3. Why 4 and 3? Because 4 times 3 is 12. Then you take the square root of 4, which is 2, because 2 times 2 is 4. And so 2 outside of the square root, and then that is your final answer. Y'all, I did this wrong. Y'all notice that?